All right. So the recorder's new. We'll hope that it still works like it did before. Apparently they sold out and got a new something. I don't know what all this is.
I can do go over 8 through 12. Can you do one for like 13?
Okay, I got the wrong sheet in front of me apparently. What? 13. Cosine 60 degrees. Well, if it's a right triangle, this was just, they're all right triangles. All these are right triangles. If that's 60, then this is 30. You know, I'm not real sure what they... Yeah, because if you put in, if this is x, and this is 2x, and this is x times the square root of 3, then the cosine of 60 would be adjacent, which is x, over hypotenuse, which is 2x, which is just 1/2.
I didn't know what it was asking. Like, I didn't know what it was asking in radian. I just put it in radian.
I literally put this in the calculator. I put cosine 60. I mean, I don't understand.
Okay, so it'll get, you'll see why when we're gonna get to unit circle tomorrow, and you'll see why it works that way. But it won't always do that. Like, what's the next? Okay, so that value does, but like, what's the next one? Like, what if I said the? Okay, tan 45. Okay, well that one's gonna work in the calculator too. Tan 45 would be opposite over adjacent, so it's x over x, which is 1. Give me another one. CSC 45. So you don't, because you're not supposed to use your calculator on this one. So cosecant is the flip of sine. Okay. So sine of 45. The sine of 45 is opposite x over hypotenuse, x times square root of 2, which is 1 over square root of 2, which is square root of 2 over 2. Which means the flip of that for cosecant is just square root of 2.
How do you know it? Why did you move the bottom down? Well, yeah, I guess.
What?
Why did you not put square root of 2 over 2? Yeah, I got that. But that's still 1/2.
No.
No?
No, it's a lot different.
Okay, I'm actually, why did you take out those?
So it said
Your final answer.
in my final answer.
Yes. Square root of 5.
In sine or cosecant? Which one are you looking at? In cosecant. Because cosecant is the flip. So if you flip this, right? And I didn't flip this one, I flipped this one because it was easier. But if I flip this one, I would have 2 over square root of 2. If I multiplied by square root of 2 on top and bottom, I get 2 square root of 2 over 2. That cancels and it leaves me. Okay, sorry. Yeah, I was getting confused on what you were talking about. What? Okay. What's your completely different way? Sine and cosine, all the trig values are the same for degrees or radians. Plugged it into what? You can't use your calculator on these. These are non-calculator. This was the very last thing, the special right triangles we did.
What?
It was the one thing that you said you weren't gonna do. Said we can do it. I just know we can do it. I said you left out the word.
Where are you getting extra
Yeah. And then I can.
That's just the pattern. There's two special triangles. There's a 30 60 90. Shh, shh, shh. There's a 30 60 90 and a 45 45 90. Those are the two special triangles. And anytime those angles are like that, they follow these patterns.
So we're supposed to have the like 2x, x, and x squared.
Yes. Yes. For those two. That's something you should have. That's on your geometry teacher if you don't. But, okay, well, that's on Brandy. But, yes, these special right triangles. So we're okay. So it's okay. That's why I took some time to show you yesterday. And you will see why. I know it seems confusing right now. When we build the unit circle, if you understand this, you'll understand the unit circle a little bit better. I will probably give it to you. I may give it to you the same day I introduce, maybe tomorrow. Probably before we leave for spring break. I don't want anything hanging over spring. I don't want any, like, you know what I'm saying? I try not to give anything over spring break. I might give an optional over spring break, but I don't usually do any type of required thing over spring break because I don't want to do anything over spring break. So if you don't want to do anything over spring break, so I would prefer to give it to you tomorrow and have it due the day before spring break, personally. That gives you a week. Okay, what's 16? Cotangent of 30. So to find cotangent of 30, let's first find tangent of 30. It's opposite over adjacent. So I'm coming back here. Here's 30, so the opposite is x. The adjacent is x root 3.
So how do you know which corner to put 30 in?
It doesn't matter which one you put it in so long as the x falls across from the 30. Because you always make your way back to the short leg, no matter what. And 30 is the short leg.
So it would end up that way, right?
Yes.
Okay.
So now tangent of 30, these would cancel. I get 1 over square root of 3, which is square root of 3 over 3. Now, whenever I flip it for cotangent, imagine this is kind of the same thing. I can flip either one of these. I'm probably going to flip this one so I don't end up with a radical in the bottom again. And I could rationalize it and come back to the same thing if I wanted to, like I did here. But really, there's no sense in doing all that extra work. Okay. Okay, can you tell me?
Yeah, it's code ESC of I definitely didn't.
And then what does it tell you to do? Find everything else?
Yeah.
All right, so let's do it. Let's just draw a triangle. Okay. I have to see it on a triangle. It helps me if I see it on a triangle. Put your theta anywhere, but it can't be the 90-degree angle. It's got to be one of those cute angles. Put it right there. It doesn't matter. Wherever you want to put it is okay. Wherever you want to put it. Now, cosecant is actually the flip of what? Sine. They're opposites, right? So if sine, that's your so, is opposite over hypotenuse, then cosecant, hypotenuse over opposite. So I got 7 and 1. Now use Pythagorean theorem to find that missing leg. Well, you did it right. X squared plus 1 squared equals 7 squared. So x squared plus 1 equals 49. X squared equals 48. Pull out the perfect square. 16 and 3. So 4 root 3. So that means that this side is 4 root 3. Now I'm ready to find all my trig functions here, right? So sine of theta is opposite over hypotenuse, so 1 over 7. We already found cosecant. Cosine. What'd you do?
I did, like, so I thought that you had to, like, find the numbers that are, like, opposite of the hypotenuse that was 7. So I did, like, 14 and 2, and then I solved
14 and 2.
this is double it. No, like, I did, like, what hypotenuse are opposite is 7, so it's 14 and 2. And then I just plugged those numbers. I did the diagram together and all that, but not with 7 and 1.
So all of your trig functions are right?
I don't know. It was just, I mean, right now they are.
1 over.
Oh, wait, I did number 1. Not that. Oh, wait, yeah. This is what I did it right, but when I'm taking square root out of the bottom, I can leave the 4 there. I try to take square root of 3.
Right.
Okay, because I wasn't sure how to take all
So I just multiplied by square root of 3,
Okay.
which gave me, this just becomes 3, and 4 times 3 is 12. That's fine. How about this? How about not? Yes, I did. All right, what else from your homework? Want me to throw the answers up here real quick? Is that? Did I? I put square root of 3? That's not the right one? Wait.
This is the first page. I thought you were showing us the back.
Oh. That's okay. Y'all just holler when you're ready for me to scroll. Scroll. Did you eat, Joyce? Try.
Who was that?
That's over there. Somebody copied that one over there on the board.
That was my favorite. Our house. I hate that one. You know what? I really don't like that clock up there. I'm not gonna think it's so cute.
Why?
I think it's cute.
I love it.
I don't know what any of those are. Like you were just drawing. I know. I don't remember that one.
All right, next set.
Oh crap. Apparently more people do than no one's always supposed to get back.
What's the, you gotta give me the thing. So it's not opposite over adjacent, it's going to be adjacent over opposite. Plus 7 squared equals the hypotenuse squared. So 11 plus 49 is c squared. So 60. What can I take out of 60? I can take a 4 out. 4 and 15. So 2 root 15.
I didn't. 4 I got that opposite equals 7 over.
All right, let's see. Sine is opposite over hypotenuse. Which ones are not fine?
I'm talking about like the opposite adjacent hypotenuse. I think we're talking about regular. For opposite, I thought it was 7 square root of 11.
No.
I don't know how I got that.
I don't either.
No, but my hypotenuse, I got just like really tired. Because my hypotenuse, I got 4 square root of 35. It's just alright.
That's fine then.
What happened in more central Wait,
All right. Thank you, all 2 of you. Okay. That means we're starting. All right. So yesterday we solved right triangles. We could do it if we were given what? An angle and a side. At least 2 sides we needed, right? We needed at least 2 sides. What happens though? Maybe I don't have that much information. What if some other key, no, call it another key, so sine is this. Find x.
y'all are so disrespectful.
Find x.
I just don't know
All right, Brooklyn's finding x for us. No, I'm just kidding. I appreciate it, Brooklyn. I appreciate it. I appreciate your support. All right. So, no, you don't know this one. This is new. All right, so Aaron says we know that this is 45 degrees. You just said, oh, that's not 45. That's definitely not 45. Oh, yeah, that. Ah, thank you, Dean. All right. Because for 3 weeks that light's been blinking, he just fixed it. 67 degrees. All right. So here's the new part. I need x, right? I don't have enough sides. So here's what I'm going to do. I'm going to set up a trig function anyway. So I've got the opposite. Now I always go from the angle that's given because I know I haven't made a mathematical error on this because they gave it to me, right? Maybe I subtracted or added wrong on this, and if I did, then if I go from that angle, everything else is wrong from there. So I always go from what's given. It's always a good rule of thumb. So if I'm looking at this angle, I have the opposite, and I need what? The hypotenuse. What trig function deals with opposite and hypotenuse? Sine. So let's set up an equation. The sine of 23 equals.
down as the opposite because there's already a number there.
That's right. This is, I don't have this side, right? But this side was given to me. So I look at what was given and what I need. And those two sides are the opposite in hypotenuse. So the easiest trig function I know, I could have done cosecant, but the easiest one, you always want to stick with the basics for this, so it makes it easier. But now the question is, how do I solve that for x? You plug this one, you do plug in your calculator for this. Now, here I need you to check something real quick. I want everybody to hit the button that says mode on your calculator. And then you see down, you have the option for degrees and radians. You see where I'm talking about? It needs to be in degrees unless, and you'll get to somewhere it's in radians, you'll have to switch it over to radians. Biggest mistake on the calculus exam, they forget to switch between radians and because it's normally all in radians. Okay? Yeah. Yeah.
She doesn't know how to do it on her calculator.
So we're supposed to be in degrees. Expensive. We're supposed to be in degrees. Degrees. You want to be in degrees here because your angles are degrees, right? Yes.
Oh, if you plug it in when it's on degrees for the other ones, it gives you the right number.
Correct.
For 13 through 16.
Unless it's a square root of 2 and you need an exact answer.
Yeah, but I was in radians, so it didn't give me it.
Yeah. All right. Now, think about solving an equation. I could multiply both sides by x here, right? And have x sine 23 equals 15. And now divide both sides by sine 23. So this is on your calculator. You're going to do 15 divided by sine 23. And what do you get? That's my hypotenuse.
So how did the x get over there?
I multiply both sides by x. 2. 2 is probably best.
Okay.
What do you mean?
Y'all are talking about, so I like this, you know.
I'm not sure what you're asking me.
Like, what are we doing?
This is in the calculator, just like 13. No, it's okay. So I set up this equation to find x, right? Because I was given the opposite and I needed the hypotenuse. So the only trig function that used both of those was sine. Are you with me now? All right, now look, listen, Linda. From here I could solve the triangle and find everything that was missing, right? Because as long as I got two sides, I can find a third. As long as I have two angles, I can find a third. And now I have all of that, okay? But using trig, if I have one angle and one side, I can find everything. Y'all with me? Let's do uno mas. No. Let's do another one. Remember, the stipulation here is that this only works with right triangles. Solve the triangle.
Oh, I did it different. Wait. Yeah, it's 11. What? Ryan.
Mm.
What is the hypotenuse? Oh, gosh. I think. I got it. Oh, wait.
I don't have a calculator.
0.14. You have to come up with a function. You have
Why don't I do what? So I chose tangent because from this angle, which is the one given, it's easy to find this, right? Because it's just 90 take away 15. Opposite over adjacent. So x over 8. Now I solve it for x. So I just multiply both sides by 8. You can't make it whatever you want. You could do that, but you would have to go from 75. 8 is the adjacent to 15 because it touches 15. If you're going from 15, then the opposite has to be x. Yeah, 15. Your theta is going to be whichever angle they give you. That's the one you want to go to. And solving it means finding all the sides. So I do have another side here that I have to find. That's that hypotenuse. So I'm going to do 8 squared plus this squared. And I'd probably just leave this in my calculator without rounding it and then just hit squared on it and add 64 to that. You got to find all sides and all angles when you solve it. But the trig is the hardest part. Huh? Yeah. That's what we're doing. Yep. So, and now, well, whenever, if you're going with, if you start out with a decimal going in, you can estimate that. Before or after you took the square root? 8.28? Approximately.
I know, I understand it.
Okay, did you do 8 squared plus 2.14 squared? And then you took the square root of it? Now do the square root of 68 point whatever. Because you got to remember that Pythagorean theorem, you got to take the square root in the end. Yeah. One more example before I show you elevation and depression.
So is that all of it? That's our solved triangle?
8.28. Yeah, that's our solved triangle. Yeah, that's fine. Solve the triangle.
That's all I'm going to see is solve the triangle on my paper.
It could be 30 and 60. No. I think it is because the two figures. I don't know how to do that. You have to Yeah, but I'm saying find one of those. None of what you're saying is making sense. So I'm sorry. I just don't.
Great observation, Zoe. If you assume what?
Like assume one is like 40 and the other is.
All right, let's think about, yes, you would be wrong. Let's think about, somebody said 30, 60, 90. So remember the pattern with 30, 60, 90. The short leg, to get from the short leg to the hypotenuse, it should double, right? So my short leg would be 2.5. Is the hypotenuse doubled that? Definitely not a 30, 60, 90 triangle. Okay, well, this you don't remember because you haven't learned this. I kind of set you up on this because, yeah, I did. I lucky did. Here, watch what I'm going to do. I'm going to pick one angle to go from with theta. It doesn't matter which one you pick. I could pick this one or this one. Again, I'm going to look at what was given because my calculations could be off. And if I calculated something wrong, I don't want my answer to be screwed up because I messed up on an initial calculation, right? So I'm going to say I need a trig function using opposite and adjacent. Oh, that's tan. The tangent of theta equals 7 over 2.5. Do we agree or disagree? The problem is what I'm looking for is the theta, and it's hooked to the stinking tangent, right? So I'm going to teach you something new. To get rid of this, I don't know why students struggle with this. To me, this is a very easy concept. Think about what cancels things out. They're opposite operations, right? Give me another word for opposite. Not reciprocal. Starts with an I.
Inverse.
Inverse. What does an inverse look like? Like if I ask you what's the inverse of, it's f to the negative 1. That's exactly right. So if I just come here and do the inverse tan of both sides, it's going to essentially, and this is not like proper math. I'm just teaching you this to help you. I don't want you to go and say, oh, well, look, well, if I inverse tan both sides, it's not really exactly like that, but it's a way to understand it. It works. All right, so theta is going to be the inverse tan of 7 over 25. Okay, inverse tans, inverse trig functions give you the degrees, give you the angle measures. So now take out your calculator and look right above the tangent, second tan. This is straight calculator. Don't make it harder than it is. Second tan of 7 divided by 2.5. What if my answer is not 70.35? What if I did the exact same thing in my calculator that y'all did and I got something different? What's probably wrong? Make sure I'm not in radians. You're exactly right, because the angle is being spit out in the degree that you're in, the mode that you're in. If you're in radians, it's spitting it out in radians. If you're in degrees, it's spitting it out in degrees. You could, but you would have to recognize that you were in, right. Yes, Brooklyn. Because for this particular problem, I needed the theta. That was, I didn't have one of the angles. Like, I didn't have any angles whatsoever. Right. Yes. All right. Let's talk about depression and elevation, and I'll stop. This is easy. Huh? Yeah, what's the other angle? What's 90 minus 70? And it's soft. Well, we got elevation and depression. Let me get a good example here. We used to do a project. I wish I still had some of them up in here. I feel like we may have it.
No, we did that. I remember this in geometry, and I remember I did not know how to do it.
Okay. So one year, whenever we used to have Algebra 3, we did a project and we made these homemade, I forget what the name of them are, kilometer? Anyway, oh, it's fine. And what happens is because angles of elevation and it's relevant this time, I promise. I know most of the time it's not. All right, here's Joyce. Angles of elevation and depression are always measured from your line of sight, okay? And they're your line of sight, and then you're either looking up or you're looking down. If you're looking up, that is obviously elevation, and that would be your theta. And if you're looking down at something, then this is your theta, and that's your angle of depression. And we can use that to estimate the heights. And this is what we did in Algebra 3 so many years ago, because this height could drop down at ground level, make a right, and I could estimate this height, or this comes down, and I could estimate this height. What? Height. Height. Heighc. Sorry, I got in a hurry. Sorry. So what we did, we took protractors, and this is I really wish we had time in here to do it because it was such a cool project. We took protractors, we hung a string on the end of them with a weight on the end of the string. We put the protractor up at our eye level, and we took it, we looked up, and it would measure the angle that your eyes were looking up. So you'd look up to the top of something. Like some people went to the gym and did the top of the gym, and some people went outside and did a tree, and some people did the top of the school building. They would pick something different, and they measured their angle of elevation to the top, how far away they were standing from the object, and they estimated the height, and then we compared it with what the height actually was. It's a really, really cool project. Well, it's that or the circle project, and we gotta get the unit circle. Yeah, and then it won't help you memorize the unit circle. All right, so let's do one, and I'll show you how this works. Let's do elevation first. We'll do this one. Ladder rests against a vertical wall. If the top of the ladder reaches a point 18 feet up the wall, what angle does the bottom of the ladder make with the ground? So always draw a picture for these. It's really going to help you. So I've got this wall. How come I clicked it? I've got this wall and this 32-foot ladder that's leaning against the wall. So here's my ladder. It's 32 feet. Yeah, it's because I'm trying to write on this paper. Once I get this done, then I'll go back over to the mirror board and transfer it, just so you can read these. If the top point of the ladder reaches a point 18 feet up the wall, what angle does the bottom of the ground make with the ladder? Feet. That means feet. Sorry.
I knew you were gonna ask that. Well, no, because I saw your hand up a second ago when she wrote up.
So this is really more interpreting the problem, setting up the triangle, and then you know how to solve it. You know how to do it from there. Yeah, 3218. 3218. Decide where your theta is. Here's your theta. I have the opposite and the hypotenuse. What should I use? Sine. No, because that's actually shorthand is actually this. We just shortened it to SIN.
One letter off.
All right, what's theta? How are you gonna find it?
5 negative 1 equals 8.
Inverse sine, that's exactly right. Theta is the inverse sine of 18 over 32, which is 34.8 degrees, because my calculator's in degrees. Depends on what you're given. Yeah. And these we're not solving all the way. We're only finding the piece of information they ask us to find. Yeah. Heck, whatever the heck.
Brian, are you allowed to say that in Ryan County? I'm allowed, no, because literally I was in English class in like 8th grade. I was like, I'm so pissed off. And then like everybody decided to get him like I said, like a bad word. Like,
Yeah. Let's do a depression and then I'll stop. From the top of a lighthouse 150 feet above sea level, the angle of depression to a boat is 28 degrees. This is my lighthouse. Now it's a lighthouse. There's a boat.
She's drawing the letter. I just put a line and called it.
oh my god, it's
I don't know why
It works though. Okay. Thank you. All right, if I draw a line down to the boat, here's the problem. Where is my angle of depression? One might think it's here, right? Huh? I want to know the angle of depression. The problem asked me, from the top of a lighthouse 150 feet above sea level, the angle of depression to a boat at sea is 28 degrees. How far horizontally is it? So y'all are saying put 28 here, and technically we could, but but remember what I said, it always goes from your line of sight. So it's always going to go out, right? This is going to be your theta, because that's your angle of depression. But it's going to be the same if you flip this around and put your triangle there. Either way, it would be the same. Just technicalities here, but yes. All right. Now, I want to know how far the boat is horizontally. So in other words, how long until it reaches how far away from the base of the lighthouse is it? So I've got, it gave me another value. 150. Right. So this is 150.
Are we finding the hypotenuse or are we finding the other side?
You're finding the other side because horizontal distance would be this. So what trig function are you going to use?
Well, let's find the other angle.
Tan.
We only have one side.
Look at what we have. Okay. Do you understand how I set the problem up?
No, I don't like
Okay. All right. Top of a lighthouse that's 150 feet tall. There's an angle of depression down to a boat in the water, 28 degrees. Well, here's the lighthouse, and so the reason this is here is because it always goes from your line of sight. It always goes straight out like lasers from your eye. And then it looks down at a 28-degree angle.
So are we trying to find the hypotenuse? What is the hypotenuse?
Theta would be like at the sailboat and not other.
Yes.
Well, if I'm straight across, right, then this is just 150. Well, because it goes straight from your line of sight, straight out, just horizontally. Like if your eyes were lasers. Yes, always, always. All right, so now you see where I got the pieces of my triangle, yes? And it said the horizontal distance, and horizontal distance would be this distance. So that's this up here on this triangle, right? So I have the opposite. I need, well, the hypotenuse would just give me this, right? That would be the distance from the top of the lighthouse to the base of the boat. What I want is how far the boat goes. Yeah. You could if you wanted to. You just be making more work on yourself, but you can. Right. So I'm going to do tan of 28 equals 150 over, and this is what I'm looking for.
Okay, so even, okay, I got that. I don't know why I thought they were like.
Oh, no, yeah. This is where, so if I multiply both sides by x, then I'd have x equals 150 over tan 28. And whatever that comes out to be is how many feet away that lighthouse is. No, we should have one after trig functions, but I really want to get to, I want to have the whole block to do, to derive our unit circle tomorrow. I love unit circles, y'all can't tell yet.
Not really? Quiz Thursday?
I'm gonna be here Thursday or Friday.
No quiz. So when
The next quiz will probably be a rando quiz on the unit circle memorization. No calculator, no anything, just unit circle.
No, it'll probably be the day after we learn.